3.6 Chain rule. One way of looking at composition function is that there's an embedding. Let's say we have a function f and it acts on g and g acts on x. So g is a function of x. So let's look at it in our notation. This is equal to, think of it this way, as f acting on g, which is a function in itself that acts on x. If I want to take the derivative of this whole thing equal to, we work on the outside. First, it's f prime of g times the derivative of whatever f is acting on. So times the derivative of g with respect to x. So for example, if we have f equal to the cosine of x squared, then the derivative of f with respect to x is equal to minus sine of x squared times we differentiate whatever is the argument of cosine. Here it is acting on x squared. So we differentiate x squared right there. So it's equal to minus sine of x squared times the derivative of x squared, which is 2x. So writing this or rewriting it or putting this in front, it'll be minus 2x times the sine of x squared. Now, we can go even further because that means f here acts on g. Now g acts on h, and h is now the function acting on x. So what we've got now is we can use the same function to illustrate. What we have here is like f of g of h of x. So if I differentiate the whole thing, it's going to be equal to f prime with respect to g times g prime with respect to h times h prime with respect to x. Let me give you an example. What we'll do is we will look at a different function here. So suppose f is equal to the cosine of tangent 3x. Okay? So what we've got here is that you have, this is our h of x, g is the tangent function, and f is the cosine function. So what is the derivative of f with respect to x? We look at the big picture on the outside. So first what we got is the cosine function. So what's the derivative? It's the negative of sine of tangent of 3x. And then we multiply by the derivative of tangent. So now we take the derivative of tangent, which is secant squared of 3x. And then we keep going because tangent is acting on a function 3x. So take the derivative of 3x with respect to x, and that's just 3. So what we have thus far is putting all the constant coefficient in the front. It'll be minus 3 sine of the tangent of 3x multiplied by secant squared of 3x. There you go. Here you've got f of g of x, like what we said, is that it's equal to f prime with respect to g times the derivative of g with respect to x. So if another way is if y is defined as f of u, if y is defined as f of u and u is a function of x, then dy by dx, that's the same as y prime, is equal to y prime with respect to u times du with respect to x. So this is just a notation, but look at the notation. See, it's almost like to get dy by dx, it's almost like canceling, but we're not really canceling because that's not, this is not a fraction, it's just a matter of notation. Now, like I said, if we have a function y, and it's equal to f of g of, say, h of u of x. What is y prime? That means the derivative of y with respect to x. Okay, that's dy by dx. And it's equal to, you start working on the outside. So it's the derivative of f with respect to g times the derivative of g, and g is acting on what? H. So the derivative of g with respect to its variable h, and the derivative of h with respect to u, and finally the derivative of u with respect to x. You see how it sort of cancels out, and we're left with the derivative of f, which is our y, with respect to x. Exercises 1 through 8, it says there that you're given that y is a function of u, and then u is a function of x, and we are asked to find y prime. Okay, I will show two ways of solving these problems. Okay, let's look at number 1. Y is equal to 6u minus 9. Okay, and u is equal to 1/2 times x to the 4th. What is dy by dx? It's the derivative of y with respect to u, but then we don't stop there. We multiply it by u prime. So it's the derivative of y with respect to u times the derivative of u with respect to x. I'm differentiating y with respect to u, and that's equal to, right here, that's equal to 6 minus 0, because the derivative of a constant is 0, so I'm not including that, times the derivative of u with respect to x, and that's equal to 4 times 1/2 x cubed. That cancels out, and we are left with 12x cubed. That is one way of solving this problem. Another way would be simply by substituting y 6 times. Instead of u, I will go ahead and directly substitute 1/2 times x to the 4th minus 9. And that's equal to 3x to the 4th minus 9. And if I just take the derivative of y with respect to x now, then that's just equal to 12x cubed. And notice that we arrived at the same solution. So you may apply both methods or whichever you feel more comfortable using.